the quiet of the room. And with that said, let's actually kick off with our lesson on inverse functions and some basic ideas around functions and inverses. So can I just, through giving me a thumbs up emoji in the chat, who has done inverse functions at school? Just put a thumbs up emoji if you have done it in school. Chavo says yes. Stabile says yes. Inverse functions. So that's inverse of the parabola, the log graph. Perseverance says yes. Haydeen Toloisi says yes. Okay. It looks like many of you have done so. Please, everyone else, don't be shy. Please put it in the chat. If you haven't, you can put a thumbs down, okay? I just want an indication of what the room is like if we have all done some basic teaching on this. Okay, awesome. So this was probably also in a recent June exam, if you wrote June test and exam. And this one says not quite, but that's fine on this one because we are doing foundations, so we will be covering the basic concepts. Right, so let's just remind ourselves, what is a function? A function is a relationship or a rule between inputs and outputs. So what does this mean? Very simply, all the functions we've been doing, so say for instance, we look at the first function that you learned. Let's just try that again. My pen is not cooperating. Let me go out and back in. There we go. It seems the Wi-Fi gets stuck sometimes and then it does this. But anyway, there we go. So y equals mx plus c. So that was the first function that you learned, the straight line. And that just meant that, so say for instance, I had a function 2x plus 2. That meant my input value is x and my output value is y. So if I take my input value, I times it by 2 and I add 2, and that's going to give me my output value. So that is a basic function. We have input values, output values. And the function involves multiplying or adding or doing something to our input value, some operation on our input value to give us our output value. Okay, so an inverse function reverses the input and output values of a function. So that's all it basically does. It just reverses it. So we represent input inverse functions with this notation, the f of minus 1. I think if you've done this in school, you've seen this. So that's just when we use function notation. F to the power of minus 1 means inverse function. So the inverse of the parabola or the inverse of the straight line, inverse of the exponential function is denoted by that little f to the minus 1. So if we look at this very simple diagram here where we have input values 2, 0, and minus 2, and then there's a function. Remember, a function is some operation that we do on those input values to get the output values. So the inverse function just basically reverses that. So if you look at the two diagrams, you'll see that my input value used to be my output value. And that's just what the inverse function does. It's just a reverse. So you would have learned somewhere along the line when you did this in school that there can be one-to-one or many-to-one relations, and that you can have functions and not have functions. So how does that work? So let's have a look at this idea of the vertical line test. So say you have a function. The vertical line test helps you to determine if your graph is a function or not. So if we look at this first example here of this graph, and that's the shape it makes. And this line here, we call it a vertical line test. So if you move it along, that helps us to determine whether a graph is a function or not a function. Okay, and so to determine whether a graph is a function, you draw a vertical line parallel to the y-axis, and if the line intersects the graph once, then the graph is a function. So if you look at this first one and you move, you can even take your ruler and you move it along this vertical line, and it keeps intersecting as you move it along. It's always just intersecting the graph once, then that graph is a function. If, however, you have a situation like this one, where you move your vertical line along, and as you move it along, you can see it cuts the graph in more than one place, then it is not a function, and that's a one-to-many relationship. Okay, so that's the vertical line test. That's a test to see if a graph is a function or not. And if it cuts the graph in one place, it is a function. And if it cuts the graph in more than one place at a time, as you move that vertical line across the graph, then that is not a function. Okay, now along with the vertical line test, we also have the horizontal line test. So the horizontal line test is to determine whether a function is a one-to-one function. So to determine if it is a one-to-one function, okay, so this one is, so once we've decided using the vertical line test that a function, a graph is a function, then you use the horizontal line test to see if it is a one-to-one function. So to determine whether a graph is a one-to-one function, you draw a horizontal line parallel to the x-axis. If the line intersects the graph once, the graph is a one-to-one function. If the line intersects the graph more than once, then the relation is not a one-to-one function. Okay, so that's a one-to-one function, and this one is a many-to-one function. If you look at the horizontal line test, it cuts the graph in more than one place at a time, so it's not a one-to-one function. Okay, so that's just some basic ideas around what is a function, what's not a function, what is a one-to-one function, a one-to-many relationship. And frankly, it's important, but it's also not that important. Okay, you might get one little question on this. They've hardly ever really asked it at the end of the year, but it is good to understand what is a function, what's not a function. And the biggest application of this only comes when we work with the parabola and the inverse of the parabola. That's really where we are going to use this idea of a function and not a function, because the inverse of the parabola is not a function, and that's what we're going to look at tonight. Okay, so all of this just comes down to the point that you must know how to determine a function using the vertical line test, how to use the horizontal line test, but it really will be maybe a 2-mark question at most, but the application comes really when we do the parabola. Right. So now when we look at actual inverse functions, how do we determine the inverse of a function? So we can have, so far we have done in this course and in grade 12, you must be able to do the straight line, y equals mx plus c, the parabola, y equals ax squared plus bx plus c, the hyperbola, a over x minus p plus q, and the exponential, b to the power of x plus p plus q. Okay, and we've covered these in this course so far. And for each of these, you must be able to work with the inverse as well. Determine the inverse equation of the straight line and the parabola and hyperbola and the exponential, and then draw those functions and answer questions around it, interpretation questions. Okay, so The inverse of a straight line is a straight line. Okay, and then the inverse of the parabola is also a parabola, but it does change position a bit, and we're going to look at it today. So this is the hyperbola, and then the exponential graph, which is what we're going to do on Thursday, that the inverse is the log graph. So logs are new. That's what you would have learned when you did this in school as well, just the log graph and how to do it. Okay, so in terms of finding the equation of these, we write it in standard form, we switch x and y. So for the inverse, x and y swap. Think of what we did here with this very basic diagram of input and output values. We swapped the input value and the output value for the inverse function. And that's exactly what you do when you find the equation of the inverse. You swap the x and the y, but you still have to make y the subject of the formula. Okay, so let's get cracking on looking at an actual parabola and how to determine its inverse. Okay, so in the grade 12, we are just going to work with a parabola that's ax squared. Okay, so you don't have to worry about having to do the inverse of the whole ax squared plus bx plus c. When we do the inverse of that, we swap the x and the y, and this is the equation we get. And let's see how we actually get there. So if y is ax squared, and we want to do the inverse, then we swap the x and the y. Like that, for the inverse. Then we're going to get y by itself, because all functions are always written as y equal to, and then x follows. So it's always, the output is equal to, and then the x's. So to get y by itself, we divide by whatever our a is. Now remember, a can be any number. When we did the parabola a few lessons back, by the way, for the newbies, all our lessons are recorded and they are available on the website. You are most welcome to go relook those lessons, and also to do the quizzes. The quizzes are available there as well. So we need to still get x, y by itself, and because it's y squared, we are going to take a square root on both sides. And because we're taking a square root, we have to do the plus and the minus. Okay, so we end up with plus minus. Okay, and that's where this comes from. That's how we get that, the inverse of the parabola. Okay, right. So when we look at the shape of the inverse is important to know. Okay, so if a is greater than 0, then our parabola takes the shape. Remember when we did the parabola, we always had a smiley face parabola if a was greater than 0. And if a was smaller than 0, then it was the unhappy face parabola. So this relates to that. Okay, so for the inverse, the shape is going to look like this. If a is greater than 0, and if a is smaller than 0, it's going to go the other way. It's actually, if you think about it, it's like the parabola sort of lying on its side for the inverse. Now, the other important thing, so there's a few important things to remember with inverses. So x and y swap. The other thing is that the inverse is the reflection of the graph in the line y equal to x. Okay, so you'll always, when you do inverse, you'll always deal with this reflection in the line y equal to x. because that's basically what an inverse is. It's just a reflection of the graph in that line. So if you ever get really, really stuck with this and you're not sure, just draw this line in for yourself, y is equal to x, and then think of making, folding your page along that line and making an imprint. And if you look at our parabola here, there's f of x. I'm going to make that pink. F of x. And if we look at our inverse, you can see how if you just visualize folding your page along this line, y equal to x, how you will end up with your graph making an imprint where that orange is for the inverse. Okay, so that's something that you can keep in mind for when you get really, really stuck. Okay, right. Now, important fact. Now, think back when we did our vertical line test, and we said for when you do your vertical line test, for it to be a function, that line can only cut your graph in one place. So if we go now and we do a vertical line test for the inverse of this parabola, and I'm just going to plonk that line down here, what happens is, as we notice, that it actually cuts the inverse in two places. Okay, so the orange is the inverse of the parabola. The vertical line test that we do to check if it's a function or not cuts that graph in two places, which means the inverse of a parabola is not a function. So that means there are two y values for every x value. And that makes sense. If you look at it, if you say this is my x value, I have a y value there and a y value here. If I go and I pick another random x, I have an x value here and another one here. So for every x, there's two y's, which makes this not a function. So the parabola is unique in that. So what we then do is we kind of do this thing called a domain restriction. Because if we restrict the domain, then we only look at certain x values. And that is going to turn our graph from being not a function, our inverse graph from being not a function into being a function. Okay, so domain restriction is a little maneuver that we do in mathematics to change a function, a graph from not being a function to being a function. Okay, Miss Coco, don't you think mathematics is sometimes a bit crazy? Hey, like we just go and restrict the domain, and now a graph that wasn't a function is now a function.
Yeah, just like make it one. Yeah, for sure.
Yeah. Okay, guys. So the domain restriction is only going to apply to the parabola. And make sure you understand why we do it. It's that whole thing about it not being a function when it's the inverse. And then by restricting the domain, we make it a function. Okay. So a lot has been said. I think we must do a question. So let's start off. And I hope you all have your pen, paper, pencils ready with your calculator. And we're going to go nice and slow and just do the first question for me. Sketch f of x is 2x squared. Okay, just sketch that on your page. It says here, clearly indicate the intercepts with the axes as well as another point on the graph of f. Now, that's very important. Don't leave out that little bit of detail, okay? So clearly indicate the intercepts with the axes as well as another point on the graph of f. I'm going to give you 2 minutes to sketch your parabola 2x squared. Maybe I can put up the notes from when we were sketching parabola. We said when we sketch, we need the shape, we need the x-intercepts, the y-intercepts, turning point, We don't have to maybe put so much detail in, because our equation for our parabola is actually quite simple. It's only y equals 2x squared. But just remember shape, x-intercept, y-intercept, where the turning point will be, and that additional point that we have to plot. Now, that additional point is up to you. You choose that point. Okay, so remember last time as well, when we had to just plot a point for the exponential graph, you are the master of your own point. Okay, you just choose your own x value and your own, and calculate your own y value for this additional point. Right, I'm going to be silent. Okay, so let's have a look. This sketch of f of x. Okay, so our parabola is 2x squared. Our a is greater than 0. So we have a happy face parabola. And our x-intercept, if you make y equal to 0, you probably found that your x-intercept was 0 and your y-intercept was 0 as well. So it's just a happy face parabola, symmetrical around the the y-axis. So your turning point is here at the origin, and then you had to plot another point. So I made x equal to 2, and then if I sub that into my equation, y is 2 squared, so then y is 8. So my point that I chose is 2 and 8. Okay, you can have another point. It's as long as you worked it out correctly and you substituted it in correctly, it's all good. Okay, so now the question asks, determine the inverse of f of x. So for the inverse of f of x, we need to do the swap with x and y. So I hope you've tried it so far, but You can do it with me, or you can try and do it on your own maybe, and then just look up at the screen to see if you got it right. But if y is 2x squared, that's my parabola. For my inverse, I'm going to swap x and y. So that's going to become x, that's going to become y for the inverse. Now I still need to get y by itself. So I start off by dividing by 2 on both sides. So I have x over 2 is y squared. I don't want y squared. I need y by itself. So take a square root on both sides to remove the square with the y. But because you are taking a square root, you need to put the plus and the minus. So final answer is y equal to plus minus square root x over 2. Okay, now that is our inverse, determine the inverse. And I really, really hope that you practice this skill and finding the inverse of the parabola. I hope that these are probably 2 or 3 marks that I hope everyone gets at the end of the year, okay? Or now in your next exam or test. Being able to convert and finding the inverse is a routine procedure, okay? So you must be able to do that. So practice, practice, practice questions like this. Swap your x and your y, solve for y. You're always going to take the square root of the y squared to get y by itself. Okay, so I hope you're taking good notes of tonight's lesson. Okay, so now for 3.3, we have to sketch the graphs of f of minus 1 and y equal to x on the same set of axes. Remember what I said about y equal to x? Y equal to x is very important when we're doing inverses, because the inverse of any graph is a reflection in the line y equals to x. That's why we swap x and y when we calculate the inverse equation. Right, so remember also we said earlier in our notes that if a is greater than 0, it is this parabola lying on its side, going kind of opening up towards the right or the left. I always get my left and my right mixed up. But let's draw that line y equals to x first. And that line is just going to go like this. And then you can draw your parabola as well. Remember what I said, if you get really stuck, just use that line y equals to x and think of making an imprint, folding your page and making an imprint of your parabola. Oh, wrong color. I want to make it orange. Okay, so this is f of minus 1. And this was f of x. Okay, can I just see in the chat, thumbs up, thumbs down? How's everyone feeling about drawing the inverse of the parabola? Please put a thumbs up or a thumbs down in the chat, or any other emoji. Well done, Tabile and Hope, Nakane, Kolo, well done. Okay, thumbs up, everyone. Excellent. Okay, now determine the domain and range for f and f of minus 1. Okay, please put in the chat your domain and range for f and the inverse of f. Tamilo's feeling strong. Yay. Okay, so domain and range for f and f minus 1. Please put that in the chat. Kolo, is that domain for f or for f of minus 1? The domain of f, x greater than 0. Okay, guys, so let's have a look at the domain of f, which is my purple parabola here. The domain is all the x values. So let's look, what x values can I use as inputs? Remember, this is a function. So what x values can I use as inputs for for my function, and I will get a y value. Any x value. If I read the graph from left to right, all of these x values here can work. Any x value. So x is an element of the reals. Any x value for f of x. That's the domain. For the inverse, the domain is x greater than or equal to 0. Okay. It can equal 0 as well. Look, the graph goes through the origin here. The orange graph goes through the origin, so x greater than 0. Now, what is my range? X between 0 to infinity. For which graph is this? Is this for f of x or for the inverse? Okay, you must just specify, please. So your range for f of x, yes, we can only get y greater or equal to 0. Y can equal 0. It goes through the origin. And y is also an element of the reals. Now, the domain, the range of the inverse. The range of the inverse, your y value can be anything. And it can be smaller than 0, it can be bigger than 0. So y is an element of the reals. And remember, for your inverse, your domain and your range will swap. Do you see, for f of x, the domain is the same as the range for the inverse. And for f of x, the range is the same as the domain of the inverse. Okay, your domain and range swap. Think back to this question. Where's our notes now on inverses? On to this basic diagram here on what an inverse is. The two swap. Your input and your output swap. That's important for the domain and the range. Okay, I want us to look further now. So this is now very nicely what the graph should look like. This was drawn with computer software, so that's very nicely to scale and everything. So let's talk about this thing of a domain restriction. Our orange graph, which is the inverse, is not a function. I think we've established that. Vertical line test, it's going to cut through the graph in two places. So we can restrict the domain. When we restrict the domain, it means we either look only at the positive x values of the original graph or the negative x values of the original graph. Okay, so just make sure that you have your head around, because some of you gave some not quite right answers for the domain and range. Okay, so if I look on this side of my parabola, yeah, look at my x values. My x values are negative. Okay, make sure you understand that all my x values are negative. If I look on this side of the parabola, my x values are all positive. Okay, I will in a minute. For Melanie, I'm just going to explain about the domain restriction. So if I restrict the domain of the original graph, we are only looking at this part of the graph. If I restrict the domain and say I'm only going to look at where x is smaller than 0, then I'm only looking at this half of the graph. This side of the graph is where x is greater than 0. So that's what it means for the domain restriction. So we say, restrict the domain where x is greater than 0. So that's where all the positive values are. And that means our domain for our inverse function is going to be all the positive x values as well. Okay, so we basically cut off part of the parabola, and we cut it off by restricting the domain, by only looking at certain values. So that's the first way. You must know that there's always two ways to restrict the domain. Okay, you can look at x greater than 0 or x smaller than 0. Okay, so if we restrict the domain and make x greater than 0, like we did this, we're only going to look at this part of the graph. So we only look at this part of the inverse. And then we can do the same thing with the negative values. That's still fine. Okay, so the other restriction, that's what this option looks like. If I'm only looking at my negative x values, then I kind of blur out or cover up the other part of the parabola where x is greater than 0. And I only look at this part and its inverse where x is smaller than 0. Okay, so that's your two domain restrictions. So back to your question, for Melanie, about the domain and range, that swap. That's just, if you have a look here, this was where we made this note. So for f of x, our parabola, x can be any number, any real number. And if you look at your parabola, the inverse of the parabola, the orange graph, the range is that y can be any real number. So that's what it means with the domain and the range that swap. If you look at the range of the parabola, f of x, that is y greater than or equal to 0. And then if you look at the domain of the orange graph, which is the inverse, that is x is greater than 0. And it just shows that your domain and your range swap. Your input values and your output values swap, which makes sense because that's what an inverse is. We swap the domain and the range. Okay, right. I think one last question before we go home. Here we go. Give it a try. Let's see how well you understood this whole domain restriction thing. I'm going to give you till about 10 to, and then we're going to go through it. Please feel free to put your answers in the chat. The chat's been very quiet this evening. Hey, Ms. Kaka, I wonder.
It's the first time we've had such like quietness in the chat. You guys are normally really good at giving us answers. Just bring back that energy.
Yeah, so please put answers in the chat. Yes, Primrose, that's right. So just specify that it's when you do the vertical line test, it cuts the graph in 2 places. And then also just the question does ask that you say how the domain must be restricted such that the inverse of f is a function again. Okay, so just make sure you put that down as well. Yes, well done, Hope. You can include equals there, hey? But I know it's a bit tricky to make the equal. I think we can just type like that if we want to put our equal. Let me try that again to everyone.
That was a direct message to me, so I'm the only one who saw that.
Let me fix that. Okay, so if you want to put your equal sign, just include it like that. I'll put it in the chat now to show you how to do your equal. Because we do include 0, everybody. Don't be, I don't know, everyone seems to have something against the 0. Okay, so we're going to restrict the domain by either just looking at the positive x's or just looking at the negative x's. Okay, it is 10-2, so I did say we're going to look at it at 10-2. How must the domain be restricted? The domain can be restricted by either doing x greater than 0 or x smaller than equal to 0. Okay, it can equal 0, guys. It's not, there's nothing wrong with the 0. 0 is a valid input for a parabola. Draw a sketch of the inverse. So let's just also draw the original. So that's going to be an unhappy face parabola. Do we choose between the negative and the positive, or we put them both? So for this question, we put them both, Primrose, but the question normally specifies how you must restrict the domain. Yes, Owami, but the question does specify normally how you must restrict the domain, either with the positive x's or the negative x's. Okay, so if we are going to do the inverse of this one, so this is an unhappy face parabola, so its inverse is going to come this way because a is smaller than 0. So it's just a sketch graph. 2 marks, just to see if you know what it looks like, what the shape looks like. Why is the inverse of f not a function? And I think someone said that. It's not a function because when we do our vertical line test, it is going to cut the graph in 2 places. Okay. And we can make it a function by restricting the domain. Right, so it is, we are almost out of time. I'm going to put this question up if anyone wants to try it at home, and we can go over it on Thursday. It's just the graph of minus x squared. See here, the domain restriction is given. The domain restriction is x smaller than equal to 0. Sketch the graph of h of x and its inverse on the same set of axes indicate the line of symmetry. Okay, so I'm going to leave you with that question. Quickly jot it down, and then on Thursday we can go through it. Okay, but let's see with an emoji in the chat, how do you feel about the inverse of the parabola? Please put an emoji, thumbs up, thumbs down, or a neutral face, whatever it is. Okay, good stuff. I know that this is one of the sections that people often really struggle with. So I really want you to do well with this and understand. Liam's giving us a... Tamelo's having a little bit of a massage. Savu, really? Okay, but go give this one a go this evening, quickly after the lesson. Just see if you can draw it. And then we will have another look along with log graphs on Thursday and quiz on Thursday. Awesome. There's a question. Yeah, you can take a quick screenshot if you need to as well. Okay, over to you, Miss Coco.
Thank you very much, ma'am. All right, guys. We don't actually have a quiz today, but we do have to take a poll. So something is going to pop up on your screen right now. Just answer however you feel you need to. I just need you guys to answer this question for me, and then I'm going to let you guys go because that's it from us at the moment. We do have a question from Apelele. She says, ma'am, will there ever be a time whereby the classes are done according to the syllabus?
Apelele, we do follow the syllabus that's set out by the department. I know that some schools change what they do and the order they do things in, but on our part, you know, because we have learners from all over, we do our best by just following what the Department of Education prescribes. So we are in line with that sort of plan. But it also depends. Sometimes we see learners really struggle with a specific topic. So we put more time into that. We offer additional classes on a specific topic, like trigonometry, and now functions. Functions, trigonometry are normally, you know, real areas of concern for learners. So then we do offer a bit more time in those topics. So, but we do, for the most part, follow the syllabus. But every school's different, and I know different schools do different things. So if we're not exactly in line with your school, it might be because your school has changed the order in which they do things. Okay. I hope that answers your question.
It did. And with that said, yeah, I think that's it. Everyone's answered the question for me. Thank you so much, everybody. And yeah, I think that's it from you and me tonight, Miss Marlies.
That is it. Thank you so much, everybody, for coming. And we see you again on Thursday. Bye.
Bye, guys.